Okay, let's talk about the next one. Next experiment. You are going to use this motor, induction motor, with this nameplate that you already have, to be the driven, to be the drive, and this is the one that can be driven. So this is the load. This asynchronous motor is drive, and this encoder belongs to this motor, but we are going to use this encoder as feedback for my induction motor, which is asynchronous motor. We already have the wires connected to that motor. We need to apply the information for this motor, information for that feedback, go for tuning, for auto tuning for this one, and then for the loop, two form of PID control tuning, and then acceleration, deceleration. Okay, the mode is supposed to be changed. In the left-hand side, this is in setup here in this folder. Everything related to motor, for example, are located here. But for example, you have access to those parameters somewhere around here. In menu 0, you can, it's kind of your favorite place. You can add some parameters in that menu. Parameters, for example, parameter for using this one is RFC asynchronous, not synchronous. Before that, I had synchronous, now is asynchronous. Okay, and I have to apply the parameters for the motor and the feedback as well. The current for this one, something that you need to find through the KI gain, and so number of poles. We know this is 4 poles, for example. These are information that we already know it. Or you can have everything here. Either one should be fine. Oh, sorry, motor. If you don't want to go through those parameters, so everything recorded to related to that motor are listed here. This is the only difference. This is not unknown. This kind of library, you have to send it drive. Frequency 60 Hertz. Current, you can change this current to 2.8. RPM 70, 25. Voltage 208. Cosine, okay, that should be fine. Number of poles 4. Make sure to send it drive the information for the motor. Okay. Then what else? Information for the feedback. Make sure this information is similar to what you had before. I think everything is the same. All right. Somebody, if you already recorded, if you already recorded on the piece of paper, please confirm if this information are the same. The 5, 16, 14, 96, 100, 16. Okay, sounds good. Since this information are the same. Okay. Then you go to tuning. Let's apply for safety reason. I go that key from here. So the power now is time for tuning. This auto tune is not a parameter; it's an extra piece of program in this VFD that you can go with, find out these parameters. A stationary first. That means the stationary receiving some parameters of the motor, like XL, RA, and so on. Next, parameters. Save parameters at the end. Okay. To start, we have to enable it. The motor is not enabled. Okay, and then Start tuning. Okay, all done. So, and back. And then this prompter, you need to write down this information, everybody. These are something that you need to consider. These prompters for a stationary tuning. Say proprietary drive. But you need to have it and make sure to have this information for me. Okay. Next is to go with rotating tuning. Oh, next, okay. Rotating tuning. Again, disable and enable. I can show you what is doing here. Just start something here and there to receive this parameter. But set failed for some reason. Remove this. Drive trip during the auto tune. Why? Over speed. Didn't we change the speed to 1800? Or let's see, I just double check your motor. 2025. Number 4 is okay. These are okay. Why is over speed? Auto tuning. Over speed is not supposed to over speed. Why did it go to over speed? One more time, why did it go this one to over speed? Again. Hopefully this time should be fine, doesn't go that fast because it go over speed. That means the PID parameters are too high. Oh, maybe the parameter for the encoder. I got to double check the parameters for the encoder. Okay, it's successfully done. Yeah, the auto tune sometimes is not as good because any kind of vibration can make changes. It's normal to run it maybe 2, 3, 5 to get the parameters. Now, these parameters, something that you need to consider: KP, KI, resistor, resistance, maximum deadline, and so on. These parameters you need to consider. The old value, new value, these are the PID parameters. Say parameter drive, and you need to write down this one for me. Okay. Okay, okay. Now everything's ready. You can go back to quick here to it. Now start. Enable it. Okay. Is it A1, A2? Let me double check. If it is what is the reference? Speed reference. Speed, okay. Maximum clamp is that one, it should be fine. A1, A2, okay, that should be fine. Something wrong with this motor. First. Something wrong with this motor now. Okay. Oh, here's one. It doesn't matter. It that strength down. Maybe I make a mistake or not. I know. If I did any mistake, 0.8 should be fine. What's wrong? That's fine here. There are fine. Something wrong with the motor. LA2. Did I apply those parameters? Did I set those up to drive? Motor parameters are fine. 8. Everything is fine here. The feedback. Fine too. We just did the auto tuning with PID. Let's take a look on block diagram. See what's going on here. Okay. For some reason, this motor is not listening. I will discover this point. I want to waste your time. If I found something here, I will certainly make it for you. That's enough for now.
Son.
Yes.
Hey, David, I just had a question. So I noticed you using, I think, 1,725 RPMs, if I'm not mistaken. Yes. I noticed it was also at, I think, 4 poles and 60 hertz. I remember previously you stated that at 4 poles we use 1,800 RPMs, and here we're using 4 poles, 60 hertz, 1,725 RPMs. What's the reason for why we're reducing the RPMs, even though we're using 4
remember
poles,
that sleep factor you had?
It's a slip factor, right?
Yeah, that sleep factor must be applied because the actual RPM cannot be the 1,800. It's supposed to be less than 1,800. That synchronous speed is 1,800. That's right.
Okay, so then I'm assuming you previously calculated the slippage and then subtracted it from the RPMs.
Yep.
Okay, so slippage would account for 75, if I'm not mistaken.
That's right.
Okay, cool. Thank you.
No worry. Okay. I'm just curious why this one is. So the reference should be fine, or it's not rotating as good. One more time. That is should be fine here. I think that one is okay. This one is okay. Fine. 560, 1090, okay. Should be fine here. Speed conversion. Speed conversion somewhere. Torque is here. Current reference. Oh. Hard speed reference select. Fine here. Back. This is fine. Speed error. Lot here. Speed control output here. Lots. Something wrong with final current limitation. Torque reducing current. Current limit. Okay, I check this one to see what's wrong. If it is so, I will upload a good experiment at the end. Okay, but it's supposed to work. For some reason, I don't know, something wrong with the motor or not. The parameter is fine. I can see the parameters are okay. For some reason that doesn't work, I'll double check it. Okay, I will stop at this point. It should be fine for you to go and check and do the completion for the lab. Question?
I'm just curious, are you planning on uploading it, all the videos today, tomorrow? Because I'm assuming we have.
I'll upload it right now.
Okay, cool. Thank you.
After the Zoom, it just needs some time to download it, and then I will do it right now. Okay.
Okay, cool.
Okay. If you have any question, everybody, the parameters are okay. You're okay with parameters. If I found something wrong with the motor, I will let you know. Okay. I will stop recording now. Stop sharing, recording. Everything seems right.